Morning students, welcome back to our YouTube channel schoolquiz.com. As you know, my name is Danish agarwal. As we have started with our chapter number 2, that is matter around us pure? Is matter around us pure? So we have covered so many topics of chapter 2, is matter around us pure? Is matter around us pure? So today we will discuss our topic Tyndall effect. Today we will discuss our topic Tyndall effect. So let's start. That is chapter number 2. Chapter number 2, that is matter around us, is matter around us pure? Is matter around us pure? So today we will discuss our topic, that is Tyndall effect. That is Tyndall effect. Tyndall effect. So what is Tyndall effect? You can see its examples in your day-to-day life, like dust particles get visible when sun ray enter through a hole. When a sun ray enters through a hole, and you can see that the dust particles are visible. It is nothing, just it is a Tyndall effect. It is just a Tyndall effect. That is what is Tyndall effect. The scattering of light, the scattering of light, the scattering of light by colloidal particles, the scattering of light by colloidal particles is called Tyndall effect. Is called Tyndall effect. And due to scattering of light, and due to scattering of light path of light becomes visible. Path of light becomes visible. That is our Tyndall effect. Tyndall effect is nothing but just a scattering of light by the colloidal particles. So as we know, in a true solution, Tyndall effect doesn't occur. Why it is so? Because size of the true solution particles is very small. That is, they will not able to scatter a beam of light. But in case of colloidal solution, so in colloidal solution, Tyndall effect occurs. Because their particle size is big as compared to true solution. For this, we take one example. Like, we will take one example. We take one example in which one is copper sulfate solution. And it's as we know that it is an example of true solution. And in this case we will take milk. As we know, milk is a colloidal solution. So suppose here it is our torch. This is our torch. Through which light rays are emitting. You can see that the path becomes visible in this case. But in not that case. Because it is a true solution and its particle size is small. Due to which they aren't able to scatter a beam of light. And its path doesn't become visible. But in case of colloidal solution, it becomes visible. So we will take some examples here. We will take one example. we will take some examples here. That is Tyndall effect Tyndall effect, that is Tyndall effect, Tyndall effect, Tyndall effect can following situations. Tyndall effect can also be Tyndall effect can also be seen in following situations. We will take here two situations. First one is when when sunlight when sunlight passes when sunlight passes passes through the canopy passes through the canopy passes through the when sunlight passes through the canopy of a dense forest canopy of a dense forest canopy of a when sunlight passes through the canopy of a dense forest the path becomes visible like due to mist etc. Like there are dust particles due to which path becomes visible. Or we can say that tiny water water droplets. Second is when a fine beam of light enters in a dark room the path of light becomes visible due to scattering due to scattering of light by dust particles. So this is all about for today's topic, that is Tyndall effect. What is Tyndall effect? The scattering of beam of light by the colloidal particles is known as Tyndall effect. In case of pure solution, Tyndall effect doesn't occur, but in case of colloidal solution it occurs because the size of particles is sufficient to scatter the beam of light. As in case of suspension, Tyndall effect also occurs, but up to some extent, because once the particles get settled down of suspension, Tyndall effect doesn't occur further. And these are the two examples. First one is that the path of the light becomes visible when sunlight enters through a hole, and path also becomes visible through canopy of forest due to scattering of light by water vapors, etc. So this is all about for today's topic, that is Tyndall effect. So thank you very much, students. Thank you very much.